Welcome back to the Chapter 6.1 Notes and Introduction to Angles. This is page 2. If you watched through the first page, you noticed that I skipped a chunk of this. Okay. So this piece right in here where we are talking about angle measures, because we are going to talk about this on this next page. Now, a couple of things I want you to notice here. As we look at each of these angles, notice that the vertex is the left-hand side, what would correspond to our origin if we were on a coordinate grid. That initial side falls along that positive x-axis. Notice this first one, positive angle, rotates in the counterclockwise direction. So opposite the direction of an analog clock. In the middle, our negative angle starts in the same place, but this time we are rotating in the clockwise direction. Notice our last angle, we are rotating in the positive angle direction. This one goes around more than once, and that's something that takes a little getting used to, but that is perfectly okay as well. So back to page 2. We want theta in the positive direction here. So we want a positive theta. We are going to start with our vertex at the origin. We are going to extend our initial side along the positive x-axis. And then our angle just needs to move in that counterclockwise direction to the terminal side. So here we have a positive theta starting at that initial side, rotating in the counterclockwise direction. For B, we want a negative angle. So we want a theta that's negative. We are starting the same way. Here is my vertex at the origin. Here is my initial side. This time, I'm going to rotate in the negative direction. Notice I'm not worried too much about how big these angles are, just that they end up where I need them to end up. Or sorry, they travel in the direction that I need them to travel in. Last one, our quadrantal angle. I will very rarely call it that. We will focus on which axis it ends up on, but these do special things for us. So the quadrantal angle just means that my terminal side falls on one of these axes. So this would be quadrantal. Notice I could also go around the other way and get to that same spot. Okay. Now, before we move on to 5, there are a couple of things we need to talk about. It is 360 degrees all the way around. So let's make a little note here. Here is my quickie axes. Initial side. 360 degrees all the way around, which also means that we could go halfway around and that's going to be 180 degrees. There's our straight angle. If halfway around is 180 degrees, that means this first quarter is 90 degrees. That's what gives us that nice right angle there. Okay. So let's talk about how to draw some of these angles. If I want a 45-degree angle, notice that is a positive 45. So I am going in the counterclockwise direction. I know that to get me to the y-axis, it's 90 degrees. Half of 90 is 45, so my 45-degree angle splits that first quadrant in half. Again, positive direction, so that terminal side ends up in the first quadrant. So let's remind us about quadrant numbers. Quadrants. Quadrant 1, we go counterclockwise. 2, here's quadrant 3, and quadrant 4. Right. So B, we want a negative 200-degree angle. Again, I start with my initial side along that positive x-axis. I know I'm going in the negative direction. I also know it's 180 degrees to get to that negative part of the x-axis, so I got to go a little past my 180 degrees to get to 200. Notice that I am not super worried about exactly where this lands. Mostly trying to figure out what quadrant I'm ending up in. So this does end up in quadrant 2. Our last angle, 405 degrees. Again, it's positive. I know once around is 360. So I'm going to go all the way around, and then I'm going to come back up for an additional 45 degrees. So again, we end up with an angle in quadrant 1. We notice that angle A, our first angle, that 45, and angle C, that last angle, end up in the same place. So they have the same terminal side. So they end, and I'm going to put that in quotes, in the same place. Mathematically, they share the same terminal side. And notice we can go around that circle as many times as we want. We could go the negative direction and get there. So this is going to come up, and it is important to know that angles that have the same initial and terminal sides are called coterminal. There's always going to be more than one way to get at an angle. Okay. So now to 6, we need to talk about some of the properties of a circle so we can make sense of how we convert from degree measures, which we're probably a little more comfortable with, to radians. Okay. So first off, a couple of definitions here. A radius that is the distance from the fixed center point of a circle to a point on the circle. Why am I having trouble spelling circle today? C-I-R-C-L-E. Sorry about that. We also have the diameter. The diameter is the distance from one point on the circle to another, from one but it has to go through the center. Okay. So back here, the formula for the circumference of a circle. Circumference is 2 pi r. 2 times pi times r. Notice that the radius is the distance from the center to a point on the circle. The diameter is twice that distance. So sometimes you see it as pi times the diameter. Same thing. Okay. A unit circle is a circle with radius. And we typically use, we always use r for radius. For radius, r equal 1. So when we talk about a unit circle, the circumference, which is 2 pi r, we just said that r was 1. So the circumference of a unit circle is 2 pi. We are going to use that fact as we convert from degrees to radians on the next page.